Hello everyone, welcome to MK Maths. I am Karthik Mansali. In last video I have discussed about the types of a function. That first type of function is one function. I have covered the definition of a one function with examples, and I also mentioned the what is many one function also. So in previous video I have covered two types of functions, one function and many one function. If you not watched that video, so you can check my description, so you will get the previous video and you can watch one function. After watching one function, it is easy to understand the onto function also. Okay, so let's start with the onto function. Definition of onto function. So onto function has another meaning. So onto function, sometimes we call it as a surjective function. Okay. For one function we call it injective function. Sometimes onto functions we call as a surjective function. So definition here, if so in previous video I have mentioned already what this indicates. So it indicates nothing but f is a function from a to b. So already f has become a function. It means it has already definition. It already satisfies the definition of a function. If you don't know about the definition of a function, in previous video I have mentioned the definition of function with example. You can also watch that video so that you will understand the definition of a function. So already f satisfied here definition of a function. So here we are denoting a f is a function from a to b. So a is the domain and b is the codomain. So is said to be, this function is said to be onto function. If now we have to say this function is onto function, then it has to satisfy some condition. Okay, if satisfies this condition, then we call this function as a onto function here. So then the condition here is every element of b here, every element of b. So in one function we have started the definition with every element of a. In the place of a, now we have considering a b. It means we are focusing on codomain now. For one function we only focused on a domain part. So domain part we defined all for one function. The definition of one function we defined all in domain part itself. So when it comes to onto part, now we move the definition from domain to codomain. So here we starts the definition with the codomain. Every element of b means here we are having a and b. So the codomain, this is b is the codomain and a is the, so this is domain, this is domain, this is codomain. So this is domain and this is codomain. So here we are starting the definition with this codomain b. So every element of b has at least one pre-image in a, at least one pre-image in a. So here if I consider here a and if I consider here 1, so if relation starts with a and ended with 1, because every time relation starts from the domain and it ends to the codomain. Okay, so now a is related to 1. So now this one is, we call this one is image of a. So this one is nothing but a reflection part of a. Okay, here a is the reflection part of 1. So for we call this one as a image of a. Okay, so we call this a as pre-image of 1. We call this a as pre-image of 1. Pre-image means we are going reverse here. We are finding the relation in reverse order. From b to a we are finding the relation. If a is related to b means 1 is the image of a, and if through one we are seeing that same relation, means here a is the pre-image of 1. This is image, and if we move this direction, now it becomes a pre-image. Okay, I understood I hope you all understood the difference between image and pre-image. This one is the image of a and this a is the pre-image of 1. Okay, so every element of b means whatever the elements contain in b, for every element there should be at least one pre-image in a. At least one means one or more than one. More than one. There should be a one pre-image or more than one pre-image. It means minimum one we should have. So it means minimum minimum one pre-image we should exist. So maximum there is no limit. So minimum there should be a one pre-image, at least there should be a one pre-image. When you consider the elements of B, there should be a at least one pre-image in A. So there should be a at least one arrow mark. The reverse, if you consider in reverse way, there should be a one arrow mark which is going towards A. Okay, so this is the definition of onto function. Every element of B, so this is the first condition. It also having a two conditions here. Every element of B has second condition, at least one pre-image in A. If this function satisfies these two condition, then we can say it is a onto function. Okay, in one function, every element of A, we focused on domain here. Every element of A has one and only one unique image. There is two conditions. It started with a domain. So definition of one function started with domain, but definition of a onto function is started with a codomain. So when we want to verify or when we want to show a onto function, we have to focus on codomain. When we want to show a one function, we have to focus on domain. One function means we have to start with the domain. Onto function means we have to start the definition with codomain. I hope you understood the difference between one and onto. One means starting with the domain, and onto means starting with the codomain definition. So let's understand clearly with the help of the examples also. Okay, by using example only we can understand the definition clearly. So let us take, I have considered here 4 functions. Okay, so these are all whatever I considered here, f1, f2, f3, f4. These 4 are always functions here because it is satisfying the definition of a function. If it is not satisfying the definition of function, then definitely we can't define or we can't express the types of a function. So to define or express the type of a function, first the given f should be a function. So that's why these 4 are satisfying the definition of a function. If you don't know the definition of a function, please watch my previous video I have mentioned in description, so that you can get clear understanding about this one and onto. Okay, so let's move with the example now. So let's consider this first example, f1. So f1 here for domain, this A is domain. Okay, this A is domain and this B is codomain. This B is codomain. Okay. Domain and codomain. Codomain means complement of a domain. So A having a 4 elements and here B I have considered a 4 elements. See, from A there is a arrow mark, and 2 there is arrow mark, and 3 there is arrow mark, and 4 there is arrow mark. If you focused on a domain, see here every element of A has one and only one unique image. There is no repetition here. Unique image is there. So unique image means indirectly we can say it is 1. Okay, it is satisfying the 1 here, 1 condition. Okay, now our main intention is to find the onto function. Our intention is to find onto function here. So onto function means we have to focus on codomain part. Okay, so let's check the definition here. So in definition we have every element of B. Okay, let's check that every element of B means A has used here. See, A has a pre-image, so there is a one arrow mark coming to A, and there is a one arrow mark coming to B, and there is a one arrow mark coming to C, and there is a one arrow mark coming to D. So every element of B is used, and every element of B has at least one pre-image. Pre-image means there should be a one arrow mark which should come from A. So then this 1 will become a pre-image to A, this 2 becomes the pre-image to C, this 3 becomes the pre-image to B, 4 becomes the pre-image to D. Okay, so now every element of B having at least one pre-image. At least one pre-image means minimum there should be a one pre-image. So 4 elements having a each pre-image, so it means it is satisfying the onto definition. So we can call it as onto function. So now this f1 is both 1 and onto here, both 1 and onto. So now let's see f2 here. So same, f2 I have considered a domain 4 elements, and codomain I have considered 3 elements here. See, if you check the first condition, every element of B, so B having a one pre-image, so there is a arrow mark coming towards A, and B, if you consider B, for B there are coming 2 arrow marks here, so no problem. And C, for C also coming one arrow mark here. It means A has a one pre-image, that is 1, and B has a 2 pre-images, 2 and 3. 2 and 3 are the 2 pre-images for each B. It means the definition says every element of A has at least one preimage, but here B having a two preimages, no problem here, because at least one preimage means there should be a minimum one preimage. If there are more than one preimage, then there is no problem. So at least meaning itself says more than one. At least one means there should be a one or more than one. So here A has a one preimage, okay, B has a two preimages, so it is satisfying at least one preimage. So B having at least one preimages here, and C also having a one preimage. So A is used, B is used, C is used, and all of the elements of B having a preimages in A. So it is nothing but onto. So this is onto, but when you check for 1 1, so it fails the 1 1, because when 1 1 means we have to focus on domain here. 2 having the image B and 3 also having the image B. So there is no unique image. 1 1 means we have to check the unique image, but 2 and 3 having a B itself image. So it is not unique because 2 is using the B as image and 3 is also using B as image. So it is not 1 1. Not 1 1 here. So this f2 is a not 1 1 function, but it is a onto function. Okay, so now let us come to f3. So f3 I have considered 4 elements in domain and 4 elements in codomain. So if same here also you can observe A, for A also having one preimage, B also having one preimage, C also having a two preimage, so though no problem. But D, here D has no preimages. So here D has no preimage. It means D is not having any arrow mark which is coming from A. It means D has not used here from A. So it means D has no pre-images. No pre-images. So D having no pre-images, it means it failed the definition, because every element of B means here every element of B not used. A is used, B is used, C is used, but D here not used. It means, so this is not onto. This is not onto, because the first definition itself is failed. Every element of B is failed here. But when you check for 1 1 means I am focusing on a domain. So 1 having a only one image, that is unique image. 2 having only one. So here if you observe 2, so 2 is having the image C and 4 is also having C. It means it failed the 1 1. So it is not 1 1. Not 1 1 means it is many 1. So it is f2 also many 1. So here f3 also many 1. Many 1. Okay. If it is not onto means, we can name it as a into function. This is into function. This is into function. Whenever we say not onto, we call it as a into function. So whenever we say not 1 1, we call it as a many 1 function. That's all. First we have to check for 1 1 function. If it is not satisfying 1 1 function, then we can call that function as a many 1 function. First we have to check the onto function. If it is not satisfying the onto function, then we can call it as a into function. That's it. So let us come to fourth now, f4. Now let us come to function fourth. Here also I have considered a 5 elements in domain, and codomain I have considered 2 elements. So if you observe here, every element of B means there are only 2 elements. B having at least one preimage. So here having a, for A having 1 as a preimage, 2 is also preimage, 3 is also a preimage, 4 is also preimage. It has more than 1. So it is well and good. It's satisfying the definition, because there should be at least one preimage. But here this particular element A has a 4 preimages. So it A is used here, and B is also used. B also having a one preimage, that is 5 here. So it is satisfying the definition of onto. So we can call it as onto function. Onto function. But when it comes to 1 1, if you check for 1 1, we focus on a domain part. See, for 1 it is not 1 also image A, for 2 also image A, 3 also image A, 4 also image A. It is not unique image. So here A is not unique image. So A is not unique image means it is not 1 1. So it is not 1 1. So not 1 1 means we can say it is many 1 function. Many 1 function. I hope you understood this. So you have to remember this. If f is not 1 1, if f is not 1 1 function, f is not 1 1 function, then f is many one function, many one function. Okay, similarly if f is not onto function, not onto function, then f is into function, then f is into function. I hope you understood the 1 1, not 1 1, onto, not onto. 1 1, not 1 1 means many one, into function, sorry, onto function, not onto function means into function. There are 4 types: 1 1, many one, onto, into. I hope you understood the examples of onto function. So just remember, if you want to check the 1 1 function, then you have to focus on domain. If you want to check the onto function, you have to focus on codomain. So when you focus on a domain, you should check there will be only one arrow mark. That arrow mark should be unique here. Okay, so if from domain A there are only one arrow marks going outside, and that arrow marks are unique, then we can say it as a 1 1 function. When it comes to onto, we have to focus on a codomain, elements of codomain. Elements of codomain should be having at least one preimage, not here unique. So at least one preimage means there should be minimum one preimage should exist. If more than one exists means it is not problem, but minimum there should be one preimage, then only we can say it is a onto function. So if in the example 3 f3, d having a no preimage here, d having no preimage, so then we called here it is not onto. Okay, not onto means if every element of B having no preimage, if any one of the element of B having no preimage means we can conclude that function is not onto function. So 1 1 function means we have to focus on domain, and onto function means we have to focus on codomain. Okay, I hope you understood this 1 1 and onto concept. And one more thing, one more definition you have to remember: if f is both, sometimes some function will be both 1 1 and onto, both 1 1 and onto function, then f is bijective function, f is bijective functions. So from this only we can, there will be a question of 5 marks. So in next video I am going to explain about how to solve the 5 marks using this type of functions. But you have to remember, if a function satisfy both 1 1 and onto, then we name it as a bijective function. 1 1 has another meaning, you have to another name, you have to remember that also. Sometimes they confuse with that name. So 1 1 is nothing but a injective, and onto is nothing but a surjective. Onto is nothing but surjective. Okay, so if f is both 1 1 and onto, sometimes they call it f is both injective and surjective, then f must be bijective. Bijective means from domain, if you see from domain it is satisfying the 1 1 condition, 1 1 function, and if you see from codomain it is satisfying the definition. So from both domain, from the side of domain and from the side of codomain, it is satisfying the both conditions, so then we call it as a bijective. So here first f3 is there, no, f1 is there, no, this f1 is nothing but we can say this f1 is bijective function. This 1 1, because f1 satisfying the 1 1 condition and f2 satisfying the onto condition, so then this function will become a bijective function. If they ask to show a bijective function, we have to show 1 1 function and onto function. I hope you understood the 1 1 onto bijective. If it is not 1 1, then it is many one. If it is not onto, then it is into. Okay, remember these: 1 1 onto, many one into. If both 1 1 and onto, then we say it as a bijective. If any one of them is failed, means it is not bijective function. Okay, hope you understood. So if you not subscribed my channel, please subscribe and like the video, so I get a motivation to do more videos. So let us meet in a next video. I hope you all doing good in your life. So let's meet in next video. In next video I am going to explain about the 5 marks question, that too with the help of these types of functions. Okay, 1 onto bijective. By the help of 1 onto bijective, we are going to solve the 5 marks question. That to fix, we can expect 5 marks from NCERT level. Okay, bye.